Welcome to this video. My name is Darshan KATGERI and I am working with Jain College of Engineering, Belgaum. In this video, we will be solving a problem on development of lateral surfaces, and in that we are going to solve a problem on square pyramids. There are a few important things that should be very clear, especially while solving problems on development of lateral surfaces. And that is, we should remember one thing, that everything is done on the true length, right? So obtaining what is the true length is very important, especially in this problem that we are going to do. This concept will be very clear after we go through the visualization that I have prepared. So let us go through the visualization first. So in this visualization, you will see that there are in fact two pyramids. The difference is that one is placed such that one of its edges is perpendicular to VP, and in this case, in the second case, it is placed such that the edge is inclined at 45 degrees. Also, this is the position which we will use, that is in projection of solids, to rest a pyramid on the corner of the base, and this is the position which is used to rest this pyramid on the edge of the base. But in development, we will see what is the importance of these two positions. Let us see the front view. This is the top view of the pyramid. This orange color is nothing but the cut section, which I am going to use now. In the front view, especially when the pyramid is placed like this in the sense like this, where you have one edge here, the front view you can see as a triangle. So this blue triangular face is visible to us. That is, the view is drawn here, and in this position we can see two triangular faces. One is this green face and one is this blue face. Now, as mentioned earlier, in development of surfaces, everything has to be done on the true length. So obtaining true length is very important. I will explain this statement. So in this position, in this particular position, you will see that none of the slant edges are parallel to the vertical plane. So the projection of these slant edges, that is this particular edge here, that is this edge here, and this edge here, they are not in their true lengths. Okay. In fact, their length I have mentioned here is 2.8118. This is not to the scale, but it has this much of length. However, if I use the same pyramid, I have made a copy of this pyramid here, and now if you see the length of this side, now observe that this particular side, this side is parallel to the vertical plane. In the top view it will be more clear. You can see that this side is parallel to the XY line, means it is parallel to the vertical plane. And in this view, we do not have any of the slant edges parallel. So the front view, in the front view, these lengths, that is this particular length here, this length and this length, they are not the true lengths, right? But in this case, because this edge or this edge, okay, they are parallel, both of them will be in their true length. So if I measure this length also, it should be, let's measure and see, it should also be 2.9193, as you can see here. This is the vertical one. However, the one which I need, yes, here, we place it here, then we can bring it. So it is 2.9193. But there might be problems wherein it is mentioned that the pyramid is placed in this position, and then we may have to draw the lateral development, right? As in one of these problems, so we will just see the problem and try to solve it. Yeah, there are two methods, parallel line development and radial line development, and we are solving a problem on pyramids. So in this case, we will be using a radial development. Okay, you can see that we have one center, and then we are drawing this arc. Then we are going to mark all these arcs here, and we will be using the radial development. In the previous video, I have explained parallel line development through one of the problems. So yeah, we will be solving this particular problem. Let us read the problem. There is a square pyramid of base 45, altitude. Altitude means height. Altitude means height. The height is 70 mm, which is shown here. Is resting with its base on HP with two sides of the base parallel to VP. So this condition is mentioned. So you can see that this condition is mentioned. So the only option that we have is to place. So two of the sides, that is this side and this side, two sides of the base parallel to VP. So we have no other option to place this. So we are going to place. So this side CD and AB, they are parallel to VP. So it has to be placed like this. Okay, and we know that if we place it like this, we will not be having the true length. So we have to obtain the true lengths. Okay, let us see how to do that. First, we will go through the problem completely. The pyramid is cut by a section plane which is perpendicular to VP and inclined at 40 degrees. It is perpendicular to VP, inclined at 40 degrees to HP. In most of the cases, the plane is going to be perpendicular to VP and inclined at some angle to the horizontal plane. The cutting plane bisects. So again, the distance is not given, but bisects means it is going to cut the axis. Bisects the axis means cut the axis into two equal parts of the pyramid. Obtain the development of the lateral surfaces. Again, they have mentioned lateral surfaces means only the side. It means we are not going to consider the base for development. The truncated pyramid. Now truncated means because it is cut at 40 degrees, it is truncated pyramid. Okay, frustum of the pyramid means this section will be parallel to the horizontal plane. Okay, we will go through all of this. We will erase all the ink, and we'll go through this. Okay. So this is the visualization. So we have a cutting plane. Let us move this cutting plane a little downwards here, like this. So if it is like this, then it is frustum of a pyramid. Okay, the plane is parallel to its base and it is perpendicular to the axis. But we want truncated pyramid because it is inclined at 40 degrees to HP. So here the angle, we can give the angle, of course, 40 degrees like this. So now it is a frustum of a pyramid. This is called as a frustum of a pyramid because this plane is inclined to the horizontal plane or to the base. So if we see the front view, this is the front view, this is what we can see, and this above portion will be removed and this portion will be retained. So this portion is removed and this portion will be retained. But now if we have placed it like this, then we have one problem, but we can easily overcome the problem by doing few basic things, that is by obtaining the true length. So let us obtain the true length. To obtain the true length, what we are going to do is we are going to draw an arc. So what I will do in this view is I will draw one circle like this. and I will trim off these sides like this. I will take the center and I will keep it like this, and let's try one more time here like this. We want it to be here, and from this center I will draw one line parallel to intersect here. Okay, let's try to erase this. uh, Try one more time here. We want exactly this point, exactly this point. Anyways, all that we have to do is we have to take this much as the length. We have to take this much as the length, and we have to rotate this until it intersects this line. This is nothing but a line which is parallel to the XY line like this. Let me just go to this more here. Yeah, now it will be more clear. From here I have drawn one circle which is passing through this, and it is intersecting here, so which is the same thing done here. Okay, so you can take from here, this is the center, from here to here you take the radius and you draw one arc here, and this is the line which is drawn, which is shown here. So this is the line which is drawn, and this is the circle. Okay, so it is intersecting here, and from this line, it's better that I draw the circle once again, because yes, let me take this as the reference and let me draw this. Yes. Just give me 1 minute. There is a circle here, and I want this one, right? All that I need is this particular point. So from this point I will draw one line which is parallel like this, and now if I join this one to this corner here, the length of the line has to be 2.9193. So let's try to do that. If everything is done properly, the length has to be that much. Yes, so let's go in the front view, and let me place it here. Let me place it here. Yes, so you can see that the length is 9.9193, which is the same as this. So now what we have done is we have obtained the true length. So you can take any of these. It is a square pyramid, so in fact most conventionally it is taken from this corner here, and then you have to extend it back such that it intersects the XY line, and then join this point to this point, and this line will be the true length. This line will be the true length. So it should be this way. It should be this way. Arc also should be this way. Okay, so or you can take arc from here also, absolutely no problem. So this is nothing but this is the true length. In this case it is 76.89 is the true length. So let us try to do this problem in the software so that it will be more clear. This is the last problem that we have done. I will insert a new sheet by right clicking insert, and I will draw the top view. I will take a square. The dimensions of the square are 45. So you can say this is 45. This is also 45, and angle is 0. Then let me join this from here to here and join this from here to here, and dimension this. We will follow the same dimension so that there is no confusion. This is A, B, C, D. So here we have A, here we have B, C and D. You can go and adjust these. So you can always go ahead and adjust these things. Dimension it. This is 45. Yes. And then next we can go for changing the thickness of the line and taking the projections from this to here, and projections from the end point to this line here, and take the intersection or the midpoint and to this line. This will be the axis. So the length of the axis is 75. If I just check it once, is 70 mm. It is given here. It is given 70 mm. This problem is given. This you have to draw. This will not be given. This will not be given. Okay. So the problem statement will be given. So this has to be 70 mm. So let us draw 70 mm. And let's place it, and we will join this, and from here we will join this, and we will join this, and we will change the type of this line. It is this much. The smart dimension, it is 70 mm, and let's rename this. This is point A, and in the bracket D, and here we have B, and in the bracket C, and this point is O dash, and this point is O1 dash, O1 dash. Of course there are dash everywhere here also, so you can just go back into these and put dash. Here also it is dash, and similarly we can go here, and this is also dash, and C dash, also C dash, right? So we will place this properly like this. This is O1, and of course this is VP. It should be capital VP. This is horizontal plane. This is X, and this is Y. Okay. So yes, this is the setup that we want. Now we have to draw this section plane. The section plane is such that it bisects the axis. So this is the axis, and we should take the midpoint of the axis. We should take the midpoint of the axis. Okay. So this is the axis here. So this is the axis, and we should take the midpoint of the axis and draw 40 degrees. So midpoint of the axis is easy to choose. Let us zoom in here. Let us zoom in, and I will select the line, and I will change the type of this line, and I will come on this line, and I will go for midpoint. It is not highlighting the midpoint because it is deactivated, so activate it and come back to the line. So yes, now it is highlighted. Click here and draw one line at 40 degrees. Okay, So like this. Again, you see it is constrained here. Angle will be constrained at 40 degrees, and then I can use extend to next and use this line till where this line has to extend. Okay, so yes, this is the cutting plane. Next we will now number this. This is 1 2 3 4. You can see here 1 2 3 4. We have to obtain this. Okay, so how to obtain this? Once we draw this, we can take the projections here and we can take the projections here, and that is how we can obtain this. Okay, so I will show you how to do that. Let me make this line continuous. Okay. And we will split this line. So split command, split this line at the endpoint of this line, split this line at the endpoint of this line, and you select these lines and you change the thickness of these lines. Similar with this case also, you split this line at this point. This is the midpoint of the line, that is what we want. So select this and change the thickness of this. So this is the portion that is retained. This portion which is shown in dark is the retained portion. Now we have to obtain the top view. So to do that, we will change the thickness of the line, and from this point, that is the end point of this, I will draw one projector like this, and from this line here, I will draw another projector like this till here. We have to change the type of the line again, continuous line, and we have to now join this. We have to join this intersection with this intersection here, and similarly we have to join this one with this one. So this is the top view. This is the top view, and these lines, again you can go to these lines and split these lines at these points which I am showing here, so that we will have all these lines as separate lines, and we can change the thickness of these lines because this will represent the cut portion. Also this line I'm going to split again, split this line at this point and split this line also at this point. And you select these lines and you change the thickness. So now you can go ahead and name this. This is point 1, this is point 2, this is point 3, and this is point 4. These can be adjusted a little bit like this. And now corresponding points have to be marked here also. So this is point 1 dash. Okay. This is point 2 dash. 3 dash is behind. So 3 dash. And here we have point 4 dash. So I will use the same text command. And here I will put it in bracket saying 4 dash and close the bracket. So now we have everything set for the to draw the development, but we have forgotten one very important thing is to obtain the true length. Okay, so to obtain the true length, what we have to do is we have to draw one horizontal line first. So that is required here. So we will take this and we will take the end point of this line here, and we will draw one horizontal line like this, and then we'll go by arc by center point. We will take this as the center and this as the radius, and we will draw one arc like this. If it is not working, then you draw a complete radius, complete circle like this. And then we can trim off these parts. So this is what is required. So we have gone this way to draw this way to draw this, and from here I have to extend it till this line, XY line, and then join it to this point. Okay. This is the true length. This is what is important. Okay. Let me move this here. This is the true length. So you can see that the true length is 76.89. So I'll just keep it here. Let us save this. 76.89 is 76.89, which is what we have obtained. So 76.89. Then now what we have to do is, because these points 1 dash, 4 dash, 2 dash, 3 dash, they are not on the true length, they have to be transferred on the true length. So all that has to be done is, we have to draw lines from here parallel to XY line until it cuts this particular line. Now this point 1 dash, 4 dash has to be measured from here, and even this point 2 dash, 3 dash, it has to be measured from this particular point. What I mean is, now we need these distances between this and this, and in that we specially need by 2 points. So please remember that you select by 2 points. Okay, otherwise it will give you vertical or horizontal distance. Similarly, we need this distance also from here to here. Okay, so we need all these distances. Okay. So we have made the base ready. Now let us go for drawing the development. Okay. Normally what is done is, basically the development is drawn here only, but because it will go out of the sheet sometime, so normally what we do is, we draw it at the side here. For cones and pyramids, it has to be actually done here only, like this. Okay. But we are going to do it at one side here. So we will copy this line and we will place it here. You can use move command to do that. And now what I will do is, I will draw one circle. So from here to here, I am not worried about the length of the arc that I am drawing. I am just drawing one arbitrary arc. And what is most important is, this has to be equal to the true length. Okay, 76.89 it has to be. Then we know that each of these is 45. The base is 45. So we are going to mark 45. So arc by center point, and you take this. The radius is going to be 45. So you can draw here like this. Again, take the intersection. And another 45, and enter. Zoom out and draw here. Then again we need another 45. Of course there are shortcuts to do all this, but I am showing it how, as you would do it on your sheet of paper. So we need another 45, 45, and mark it here. So we have 1, 2, 3, 4. I think we need one more. So again from here you take the intersection, and another 45 you can mark it here like this. And then we can use extend to next command, and we can extend it. Now I realize that it has gone out a little bit, so I will select all this by dragging a window, and I will bring it inside. Then I will go to line command and I will change the thickness, and I will join these from here to this intersection here, and again from here to this intersection here, and again from point O, that is point O of course, point O to the intersection, and again from this point O to this particular intersection. So once this much is done, this point is O, this point is O, this point is A, this will be B, this point will be C, this point will be D, and this point, guess what, will be A. Okay, so A, B, C, D, A, B, C, D, back to A. Okay. Next, we have to join these by straight lines. Now you select this, change the thickness to 0.5 and join these by straight lines. So you take the end point of this line like this, you take the end point of this line like this. I am using pan. Pan is I am just pressing and holding the mouse button and moving it. Come to this line and press, release the left mouse button, press the middle mouse button and hold it and drag it, and yeah, like this, and save it of course. So now we need the distances. Okay, so let us mark point 1. We know that point 1 is on OA. This point is O here, this point is O, and O1, this point is O01, O01, like this. Yes. So let's move this a little to the side. So you can see that point 1 is on OA, right? So point 1, the distance of point 1 in this view, point 1 is here, is 52.65. So you have to measure 52.65, again arc by center point. So from this point you measure 52.65, and say arc. So you can draw one arc here. Then we will mark point 2. Mark point 2, that means we need this distance 2 from O dash to 2, which is 30.28. So again we will come back, select this point, 30.28, and this has to be 30.28. Yes, and that will be placed on point on OB. Okay, point 2 is on OB, point 3 is on OC. So point 3 is also 30.28 from O dash. So another arc by center point, and that will be done here, 30.28. So it is 30.28. Say enter, and you can draw one arc here. Then again point 4 is 52.56. So again select arc by center point, 52.56. This is the center, 52.56. You can draw this arc. And then finally we need one more arc, and that arc will also be 52.56 because we are marking point 1. 52.56. This arc, this is not important to us. Yeah, we will draw the arc, we will sweep it manually. So now these are the points. So we will name these points. This is point 1, this is point 2, this is point 3, this is point 4, and this is point 1 again. Now we have to select line, and we will turn off the midpoint and select line, change the thickness, and join all these points. So we have to join this and this, and we have to join this and this, we have to join this and this, we have to join this and this, and we have to join this and this. So once this much is done, we can select these lines and split these lines, which we will do now. Select this and split it at the end point of this. Select this and split it at end point of this. Select this, split it at end point of this line. Select this line, split it at the end point of this line, and select this line and split it at the end point of this line. And we can select all these lines now. The purpose of selecting is because we want to split the lines, is because we want to select only these lines to make them dark. That's the only thing. Otherwise you can go ahead and draw separate lines to make them dark. So this is the required development. You can go ahead and write, this is the development. This is the development of lateral surface that is required, right? Yes. And of course we can make some fine adjustments in the end. We want it to be like this here, and then we will select all this, and we want it to be like this. Save it as .dft, and afterwards you can save it as, see here it will show it is saving it as .dft, and when I press this button this will be saved as .dft, but we have to save it as PDF also. So again I will save it on my desktop, and I will save it as .pdf. This is one, and this is now second problem. You can say two problems, and say save. So this is the complete solution. You can go ahead and show these arrows also. We have moved here like this, and don't forget to change the color of this. Go here and change the color of this. Say OK. Save it. So this is the complete solution also. Yes, so the most important thing to understand here is that we have to obtain the true lengths. We have to obtain the true lengths. Okay, so I think this will make it more clear. So this is the solution which is solved. Yes, we can give this as 45. This has to be 45 because we have taken it from here. Right, now we have completed all of this, and this is the complete solution. You can practice this on the grid sheets. You can practice the same problems. Again, you notice that it is a radial development, and the problem in the first video on this development was on a parallel line development. So we can practice this on the grid sheets. So we will stop here. Thank you.